Okay, so we have already talked about the cardiac cycle, and now we're going to relate the cardiac cycle, the activity of the heart, through a graphical representation, which is also referred to as the electrocardiograph in medical terms. So it is a graphical representation, like I said, of the electrical activity of the heart. And when we are obtaining a standard ECG, the patient, let's consider this to be a patient, 3 electrical leads are placed on the body of the patient. So one lead is going to go onto the wrist of the left arm, another one on the wrist of the right arm, and the third one on the left ankle. So that makes a triangle, and that sort of reads the electrical impulse of the heart. Now, the ECG of a standard person, or the standard ECG of a person, would look something like this. Now, we are going to discuss all the waves, and we are also going to relate to the different activities that are going on inside the heart, and which is relating to each of the waves. So starting off with the P wave. So this is the P wave. This is the P wave. The P wave is basically nothing but the depolarization of the SA node. And with the depolarization, what comes up? The depolarization makes the contraction of the right atrium. So when the SA node, it is firing, it is giving the electrical impulse, the right atrium, it contracts. So this is the P wave. Now you can see after the P wave, there is this little, there's this little flat line. So this is the delay. This is the delay of the impulse, or the electrical impulse, by the AV node. Now we know that the SA nodes, it fire the electrical impulse, it goes and it gets received by the AV node, from where it goes to the bundle of His, from there it goes to the Purkinje fibers, and that's how it is transmitted throughout the heart. So this delay, it ensures that the contraction of the right atrium, which we talked about in the P wave, the contraction of the right atrium, this is complete, and all of the blood is drained into the right ventricle. Right. So this is why there is this flat line and this significance of the delay. Next comes the QRS wave. Now the QRS wave, this pertains to the ventricular depolarization. Ventricular depolarization. And also, we had already talked about the atrial contraction, or the atrial depolarization. In this stage, when there is this QRS, the atrial walls, they relax. So the atrial repolarization. Right. Now, again, you can find that there is this flat line, which again signifies a bit of delay. This delay is because you want the ventricles to depolarize, and the contraction would cause all the blood to go out of the heart. So this signifies the completion of ventricular depolarization. That is the significance. After the delay, you again have the T wave. It is another wave. You have the T wave. Now the ventricles have depolarized. Now it is time for the ventricles to come back to its original position. So we're going to call this the ventricular repolarization. Right, again we have a flat line, so this signifies that the ventricular repolarization is complete, because you want the ventricles to again relax to its maximum so that it can take up the maximum blood from the atria. And finally, you have something called the U wave. You have something called the U wave. So the significance of the U wave is the repolarization of the Purkinje fibers. Right, so that was the whole cardiograph. Let's go through it once more. So the P wave is when the sinoatrial node is firing the impulse, and the depolarization occurs when the contraction of the right atrium starts. Now, as the right atrium contracts, the blood needs to flow completely to the ventricles. That is why the contraction, after the contraction, there is a bit of delay after the next ventricular depolarization. So this delay is signifying that the AV node is having a delay of the impulse, because the complete blood that was present in the atrium is drained into the ventricles. Next comes the Qrs wave, which is signifying the ventricles to contract, that is the ventricular depolarization, and along with that the atria, which was in its depolarized mode, it becomes repolarized. Then again there is a delay which ensures that all of the blood that was present in the ventricles, it goes out of the heart. So the completion of the ventricular depolarization, it is signified by this flat line. Then comes the T wave. The T wave signifies as the ventricles have depolarized, the ventricles need to get back to its relaxed state. That is why the ventricular repolarization. Finally, again we have the flat line, which signifies the repolarization is complete by the ventricle, and the completion is marked by the U wave, which signifies the repolarization of the Purkinje fibers, which was carrying the impulse throughout the heart. So this completes a whole cycle of the heart, that is the whole beating of the heart. So that was it for this video. We are going to look at the blood vessels, that is the arterial veins, in the next video. And finally, we are going to look at the double circulation in humans. So all of that in the next one.